Hello and welcome to this video tutorial. In this short video, we're going to be looking at questions 1 through 9, solving a literal equation for a specified variable. Remember, the algebra in this is the same algebra that we've been using since the 7th grade, okay? If we see add, the opposite of that is subtract. When we see multiply, the opposite of that is divide. When we see divide, the opposite of multiply. When we see square, the opposite is square root. And when we see square root, the opposite is square. The only other thing that I would add to that is a trick that we showed in class called the switcheroo. Just to remind you of how the switcheroo works, if I had a question like 50 equals 100 over x, the switcheroo meant that I take those two and swap them, meaning I swap the denominator with the other side of the equal sign, and it would turn into this. Okay, so we're going to apply the switcheroo when necessary, just to make the algebra more efficient when I'm solving for the denominator. Okay, another thing that popped up every once in a while was dealing with a fraction, in which case you multiply by the reciprocal of the fraction. So something like 2/3 x equals 18, right? I would multiply both sides by 3/2, which is the reciprocal of 2/3. So cancels, cancels, okay, and then I would get x equals, right, 27. So we're going to be taking a look at some of these as we go through today. All right, let's begin. So in this first section, we're taking these 9 physics equations and we're going to solve them for the indicated variable. So in the case of number 1, we're trying to solve for t. But in order to get t by itself, you're going to have to get rid of the half, the g, and the squared. So let's start off with the half. The first thing I can do is multiply both sides by 2. And when I do that, I'm going to rewrite this. I'm going to get 2 times delta y means the change in y, equals, you notice that cancels, gt squared. Okay, so we're one step farther. Now we have to get rid of g and squared. Okay, let's go ahead and divide away the g, because the opposite of multiplying by g is to divide by g. So you can see the g is going to cancel on the right side. Okay, and so far we have 2 times delta y divided by g equals t squared. Our last step is to get rid of the square. So the opposite of a square is a square root. So we're going to square root both sides. Make sure you write it over the entire top and bottom as you do. Okay, and we're done. We got t by itself. T is equal to the square root of 2 times delta y divided by g. And then just make sure to box or circle your final answer if you're finished. Okay, remember to pause or rewind the video as you need to in case this is going too fast. Number 2, we're solving an equation that says delta x equals, now this little symbol right here is the that little subscript 0 stands for naught, N-A-U-G-H-T. It's kind of pronounced just like N-O-T, okay? But it's N-A-U-G-H-T. And usually what it stands for is initial or starting quantities. So if V stands for speed, then V naught would be the starting speed or the initial speed. So anyway, we're solving this equation for V naught. Now, in order to solve for V naught, you have to get rid of the t and get rid of the whole 1/2 at squared and bring all of that over to the left-hand side. So here's what I'm thinking. Get rid of the part that's being added or subtracted first. So I'm going to start by subtracting 1/2 at squared to begin with from both sides of the equation. Okay, and if I rewrite this, I get delta x minus 1/2 at squared equals, well, what's left over? V naught times t. Now, you only have one thing left to do. You have to get rid of t in order to get V naught by itself. Well, since they're being multiplied, the opposite of multiplying by t would be to divide everything by t. Okay, do that, we're done. And V naught would equal delta x minus 1/2 at squared over t. Okay, and we're just going to box and circle our final expression. Okay, and we're done with number 2. Number 3, we have v equals the square root of 2 times a times delta x, but you're solving it for delta x. Now, the first thing I'm thinking is that delta x is trapped under a radical, so the first step I might do would be get rid of the radical. Well, the opposite of square root is to square both sides. So let's actually begin by doing that. So if I square the left, I get v squared. If I square the right, it just simply gets rid of the radical, and I'm left with 2 times a times delta x. Now, in order to get delta x by itself, I need to get rid of 2 times a. Well, 2 times a is multiplied times delta x, so the opposite of multiplying by 2a would be to be dividing by 2a. And that's exactly how we'll finish this. So delta x will equal v squared over 2 times a. Okay. Number 4, we're solving for v final. Okay, so how do we do that? Well, delta v is the change in velocity. So delta v is actually v final minus v initial. It's the final speed minus the starting speed, gives you the change in speed. So that's the first thing I'm going to do is rewrite delta v as a change in speed. So a, if I rewrite this, a is equal to v final minus v initial divided by t. Now, the first thing I notice is I got to get rid of this fraction here. Okay, so if I'm dividing by t, the opposite of that would be multiply by t. Just make sure you do it to both sides. Okay, rewrite it. And we get a times t on the left equals v final minus v initial on the right. Well, I have to get v final by itself. So the way I do that is to get rid of the minus v initial. Well, the opposite of subtracting v initial would be to add v initial to both sides. I'm going to do that. And we're done. V final equals v initial plus a times t. Okay, number 5. We're solving a equals delta v over t for t, which is the denominator. This is a perfect opportunity to use the switcheroo. This is a one-step solve. T equals delta v over a, and we're done. These ones are nice. Okay, number 6. Now you're solving for m2. So in order to get m2 by itself, you have to get rid of g times m1 over r squared. Remember, g is multiplied times the top, not times the bottom. I know it's kind of written here in the middle, but remember, everybody, this is g over 1. Okay, so you have to multiply by the reciprocal of g m1 over r squared, and that'll help get m2 by itself. So the first thing I'm going to do is I'm going to rewrite this whole thing. Okay, so I got f equals, but I'm going to space it out a little bit, g m1 m2 over r squared. And I'm going to multiply both sides of this by the reciprocal of what I want to get rid of. Well, the reciprocal of what I want to get rid of is this. That gets me m2 by itself. So what's the reciprocal of gm1 over r squared? R squared over g times m1. And I do that to both sides. Cancels, 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 cancels. M2 is by itself. So M2 would be F times R squared divided by G times M1. Okay, number 7, it's the same equation, but this time you're solving for R. Now, the first thing I would do is I would isolate and solve for R squared, and then you can get rid of the squared. Well, since R is in the denominator, how about we start with a switcheroo? And we switch with the F over on the other side. So if I do that, we get R squared on the left equals G, I'm gonna write G up top with those two there, times M1 times M2 divided by F. One last step. Square root both sides. And we're done. R would equal the square root of G times M1 times M2 divided by F. Okay, number 8. We're solving this equation for L. Now notice L is trapped under the radical. So the very first thing I might do is I might square both sides. So I'm going to square the left side t, and I'm going to square all of the right side right here. And I'm going to rewrite this. This will get written as t squared on the left equals, now if I square the 2 pi, I get 4 pi squared. Okay, and when I square the radical just goes away. So I'm left with L over G. Okay, now remember, I am supposed to get L by itself. So that means I have to get rid of 4 pi squared over G. Okay, well, I'll do that by multiplying by the reciprocal of that fraction. So let's multiply both sides by the reciprocal of 4 pi squared over G, which is G over 4 pi squared. Make sure you do that to both sides. Over 4 pi squared. Cancels, 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 cancels. L is by itself. Okay, so L would be equal to t squared G, or you could write it as GT squared. The order doesn't matter. Over 4 pi squared. We're done. Okay, and in our last one, we're going to start off exactly the same way. We're going to go ahead and square both sides to get rid of the radical because G is trapped under the radical. And if we do that and we rewrite this, we again get t squared equals 4 pi squared L over G. Now G's in the bottom, and we can do the switcheroo to isolate the G. And so we get 4 pi squared L over t squared. So this complicated equation really just involves 2 pretty easy steps. I hope you found this tutorial to be helpful. Thank you. That is all.